Welcome to our section on how to work with real-time data in Microsoft Fabric Eventhouse. An Eventhouse in Microsoft Fabric provides a data store for large volumes of data. An Eventhouse is optimized for data that represents time-based events, as is common in real-time data analytics scenarios. It's designed to handle real-time data streams efficiently, which enables organizations to query and analyze data in near real time. It's common in Microsoft Fabric to use an event stream to load a stream of real-time data into an Eventhouse. You can then query the data using Custom Query Language or KQL, or you can use a subset of SQL to query the KQL query set. In this section, we will discuss what an Eventhouse is, as well as how to create an Eventhouse in Fabric. We will also use KQL to query our real-time data and create functions and materialized views. To create an Eventhouse, you must be working on a workspace with a Fabric capacity that supports real-time intelligence Fabric capabilities. You can then create one or more Eventhouses for your data. An Eventhouse contains one or more KQL databases where you can create tables, stored procedures, materialized views, and other items to manage your data. After creating an Eventhouse, you can then use the default KQL database or create a new one. To get your data into the KQL database in the Eventhouse, you typically import it from a static location, such as a local file, OneLake, Azure Storage, or a sample dataset, or from a real-time source like the Azure Event Hubs or a Fabric event stream. To make it easier to develop queries, Eventhouses include support for one or more KQL query sets, which simplify querying development by providing sample syntax and coding utilities. A default query set is provided, and you can create more if needed. KQL syntax is intuitive, concise, and includes a wide range of functions and expressions that make it easy to perform complex data analysis efficiently. The simplest KQL query consists simply of a table name. For example, to retrieve all the data from a table named automotive, run the query with just the word automotive. The KQL query is the equivalent of the SQL expression select asterisk from automotive. Given the potentially huge size of tables based on unbounded streams of real-time data, it's best to use the take keyword with the number and tell it how many records you'd like to have returned. This would be similar to the SQL select top 100 from asterisk from automotive. Note that the use of the pipe character on each new line to separate the clauses of the query. Your KQL query here is querying the automotive table and filtering the records using the where clause for the fair amount greater than 20, and project is listing the fields that we'd like to have returned: trip ID, pickup, date, time, and fair amount. Lastly, we'd like the results to be sorted in descending order by pickup date. It is also shown here translated into T-SQL. Note that you can use either the KQL query or the equivalent SQL query to retrieve data from a table in the KQL database. Remember to use the -- to let it know that you're using T-SQL, and the command explain to have it translate your T-SQL to KQL on the fly. There are advantages to each language in this case of KQL databases. KQL is the preferred language because it's more simple over looking at T-SQL, and its performance in handling large amounts of data, it's more efficient than T-SQL. One major disadvantage of using SQL over KQL is that it's not the native language of the engine, so it must go through a transformer, which prevents it from being published to Power BI directly from the query set. Ultimately, you may want to create real-time dashboards or Power BI reports based on your queries. so it can be useful while exploring the data in the query set to create quick data visualizations. KQL query sets also include the capability to render the results of the query as a chart. You may want to consider using Copilot to assist with queries. When your administrator has enabled Copilot, you see the option in the Query Set menu bar. Copilot opens as a pane on the side of the main query interface. When you ask a question about your data, Copilot generates the KQL code to answer your question. KQL databases in event houses are optimized for large volumes of real-time data. To get the best results, there are some good practices you should bear in mind. Tables based on streams of real-time data can become large. Minimizing the data returned by a query can help optimize performance and prevent errors due to exceeded data limits. You should consider filtering columns using the project keyword to retrieve only the columns you need. For example, the following query returns only 4 columns of data: trip ID, vendor ID, pickup date time, and fare amount. Use the where keyword to filter the rows returned based on specific criteria. Given that real-time data usually involves a temporal or time-based element, KQL provides strong support for filtering based on time, as does this query using the ago function to restrict results to only the events that have occurred over the last 30 minutes. Sometimes you don't need to retrieve data at an individual event level. Instead, you can summarize the data to help you analyze patterns, often based on time intervals. For example, the following query retrieves the average fare collected by each taxi vendor each hour in the events ingested within the last day. While you can often achieve your analytic goals by querying tables and using built-in functions and operators, KQL provides some advanced features that you can use to create new objects that encapsulate data or logic that are frequently needed to be used. A materialized view is a summary of data from a source table or another materialized view. The view encapsulates a summarized statement. For example, the following statement creates a materialized view that contains the number of trips for each vendor each day. Running this statement creates a materialized view that ingests existing data that uses an asynchronous operation to create the materialized view with a backfill equaling true. Without backfill equal true, it wouldn't immediately populate it with the data in the existing table. The view would be populated as new data, as new data is ingested into the source table without the backfill equaling true. After creating and populating the materialized view, you can query it just like a table. Notice we are querying the trips by vendor materialized view, looking for the 3 fields: pickup date, vendor ID, and trips, with the results sorted by pickup date descending. Materialized views are listed in the Materialized Views folder for the KQL database, where you define them in the Event House page. KQL includes the ability to encapsulate a query as a function, making it easier to repeat common queries. You can also specify parameters for a function, so you can repeat the same query with a variable value. To create a function, use the .create-or alter function KQL command. For example, the following function retrieves the trip ID and pickup time for trips with at least the specified number of passengers. To call the function, use it like a table. In this example, the trips by minimum passenger count function is used to find 10 trips with at least 3 passengers. Note that the number of passengers is the parameter. Now let's see how to work with data in a Microsoft Fabric Event House.
In this lab, we're going to talk about how to work with data in a Microsoft Fabric Event House. And predominantly, we're going to talk about queries. We're going to query using KQL and also SQL as a little contrast so you can see how they work. Now, I already have my workspace created here. So what I'm going to do is I'm going to create an event house, but I'm going to do it a little bit differently than I've done in the last couple of labs here. And what I'm going to do is I'm going to go over to workloads and I'm going to click on the option for real-time intelligence. And in here, what you will see is that we have a number of options for setting up real-time intelligence. But what I'm going to select, though, is I'm going to have it explore real-time intelligence, the sample. And when we do this, what you will note is it's going to create for us the event house. So, and it'll create the KQL database too, as you can see. It's going to put everything together for us in one location and the query set, so everything. So it's kind of a fun option to choose, especially if you're new to making event houses and working with our real-time intelligence. It could be a way to really save you a little bit of time. And then note too, you can go in and find out extra information about some of the things we've already talked about. The dashboard query set, event stream, and real-time hub there. I'm going to come out of this window and you can see we have automatically set up for us the bike stream table. So this is set up and it's streaming in bike information, which should be a little more familiar now from our last section. And then we have a query set and a database that we can work with here. So we're going to spend some time running some queries, and we're going to focus on the KQL queries. Now remember, KQL is going to be case sensitive. So when we refer to working with bike stream has an uppercase B and the rest of it's lowercase. So if I'd like to query, I'm going to have to put it in the right case or it will not find it. So let me go ahead and paste this in. We're going to have it show us the first 100 records there from bike stream. And you see it's very simple syntax that gives us really a lot of bang for our buck there with the first 100 records shown. Then what we're going to note is we can also ask it for particular fields to be returned, and that is with project. So I'm going to change this up a bit here, and I'm going to include project. I only want to see in the results set street and number of bikes, and only give me the first 10 is what we're saying with this. So I'll go ahead and run that. And you can see our results there. So that looks pretty good. And then what you'll note too is I can also ask it for fields that maybe, I want to change out their names. So let me run this one more so you can see what it looks like initially. And I want to change this field out right here. And I only want to see two fields. Street and then number of empty docks, but I'm going to put an alias on it instead of having it come up with that name. So you can see right here, project is how we point to the fields. And when I run this, we're going to get 2 fields in the results set and the top 10 records. So we can see that. That's hopefully I think it's very straightforward, very easy to work with. Now we could also have KQL do some math for us. And how we can have it do that is we can do the aggregate. So I want to summarize that signals that I want to do an aggregate here. And what I'd like to do is I'd like to see the total number of bikes summing no bikes. So let's run this and give you a little look at the result there. So we get that total number of bikes field returned. Notice it's inside of square brackets and also quotes there. And then it's giving us the sum of the no bike field. So we can see that there. So that's an easy one. And then we can go a little further with that. And maybe what we want to do is modify that just a bit. And what I'm going to do is I'm going to have it summarize the no bikes like we had with that last query. But then I also wanted to have it done by neighborhood. So a little bit of group by if you would like here with KQL. And then I only want to see the two fields, neighborhood and total number of bikes returned. So that could be helpful there. Another really helpful one is looking for empty cells, nulls. And we do have the ability to do that. We have a case statement that we're going to run here. So we're still going to be grouping by it the sum of no bikes, but we also want it to return the neighborhood field, and we want it to look to see if it's empty or if it's null or if it's unidentified. And then we want that information returned to us here. So we'll go ahead and run that there. And there you see the neighborhood and then the total number of bikes it's including. So we can see that for each of the places where we have empties, nulls, and unidentified. So pretty slick, actually, using a case statement like this. When we compare this to SQL, you're going to think SQL has a lot of syntax, and the KQL has really streamlined that, which we hopefully find very helpful. Now, we could also, if we wanted to, have it do some sorting for us. So I'm going to have it do a little bit of sorting here. I'm going to add in another line to have it do a sort there. And let's see how this one runs for us. There we go. So we can have it sort ascending as our example here. Now, if we don't want to use the phrase sort by to have it do a sort, which I think makes perfect sense, we could change this from sort to order. So it works with both. It works with sort and order by. You can choose either one. So order by or sort by, and we hopefully get the same results there. Okay, so you can see some options when it comes to running these queries. Now I could also do a little bit of filtering here if I'd like to do that and include a where clause. So I can include that here. Notice the where clause where the neighborhood is equal to Chelsea. So I want to do all the things that we were just talking about, but I want to do it where the neighborhood is equal to Chelsea. So then we get down to that one record and just see that Chelsea record for the Chelsea neighborhood. Okay, so KQL. I'm hoping you're becoming a fan. Nice, easy ways to do our queries. We could also, however, move into T-SQL. And we have a query that we can run that does the same thing as the first one we ran, where it tells us the first 100 records from bike stream. So that makes it very easy. We could do that other option, which was the take option we saw earlier. This is a little more syntax, but probably also a bit more common. This could be something that we're very familiar with SQL as opposed to KQL, but we could get used to KQL, especially with the less syntax that it does. So what I'm going to do is I'm going to have it give me the top 10, but then I'm going to also have it give me two fields. So street and no bikes. So we have that there. That's a good option, easy one to run. And then if I have maybe a field name that I want to change out, I can do that too. And I can do it with the as command. So we saw that in the KQL. This is maybe a little wordier, but again, maybe also a little more, something we worked with before rather than, KQL might be a little less familiar. So we have that. We could also have it do some math for us and do an aggregate. So here it is doing a sum, very similar to the KQL, but with this one, we're having it sum the number of bikes or no bikes as total number of bikes. So then, so we want to know that the number of bikes is total number of bikes from bike stream. So that was familiar and similar to the one we did with KQL. And then here what we want it to do is we want it to give us the neighborhood and then select the sum of no bikes as, and then we're returning it as the field total number of bikes. And then what we're going to do is we're going to include the group by with that. So have it grouped by neighborhood. So our results will be grouped by neighborhood there too. And then what we can also do is we can have it go look for values in a field that could be missing, could be also null, or could have maybe the word unidentified somewhere in there, but we can set that if we'd like with this. So this is using a case statement. So if it's null or the neighborhood is equal to, then if the neighborhood is equal to nothing, what we want it to do is we want it to change a few things around. So this is that case statement that we saw a little earlier with KQL. And this is maybe a little bit more syntax. It does get the same effect where we can get the results of those places where we have nulls. And so what we can do with this is it's the when and else statement that we're working with here. So this could be helpful, but as we saw KQL a little earlier, a lot shorter syntax to write a case statement. So we can write it out in T-SQL, a little more involved. Here's another option here where we do that same statement, but what we do here is we set it up so that it is ascending. So we have this statement, we'll run that. So we're sorting our results. And just like we filtered before, using our option with the where clause, you can use the where clause here, as you know, inside of T-SQL. It's, in this case, since we have group by, we're using having as our where clause. So maybe a little bit more syntax, maybe more familiar, but similar results as we can get with KQL. So hopefully this is helpful, getting a chance to see how you can run a few queries here in our sample database in our event house here with the data using real-time for Fabric. So I hope this was helpful. See you in the next recording.
Now it's time for our knowledge check. Question 1. What is an event house? Answer: a data store for real-time data in the KQL database. Question 2. What is the purpose of using the project operator in KQL or the custom query language queries? Answer: to specify which columns to include in your query output. Question 3. How can you create a reusable parameterized query for the KQL database? Answer: create a stored function. In this section, we talked about how to query tables in the event house using KQL or SQL. We looked specifically at how to filter columns and rows and how to summarize data. Lastly, we talked about using materialized views and stored functions for our queries. Thank you for joining us. See you in the next section.